All right. So now we're focusing on series, and the series is a way to add up the terms in sequence. So summation notation, which is what this symbol is the sum of a term of the sequence denoted as this. Okay, so your sigma notation with k equals 1, that's going to be your index, okay? The top term is called the stopping number, and then AK is all terms A in a sequence. So let's look at an example here. If you have a series where k is equal to 1 as your index, and 7 is your stopping number, and your term is k squared, what this would indicate is you start at 1, that's your starting number, so you could do 1 squared, and you add up all the terms from your starting number to your stopping number. 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared plus 6 squared plus 7 squared, and then you stop at 7 because 7 is your stopping number. All right, so let's make sure we're focusing on the material here. All right. So the index of summation, that's just fancy way of saying that's the k value. That's all that's saying is this is the number that you start at. So this is the term in the sequence that you start at. So term in the sequence that you start at. That you start at. So for example, when you have the series k is equal to 2, where this is your stopping number is 9 of 4k, you're going to start when k is equal to 2. So right here. All right, and the variable k could change. It could be I, it could be n. So don't always expect a variable k. You could have different variables. All right. A geometric series is the sum of all terms in a geometric sequence. All right. So here's what a geometric series could look like. You have sigma notation. Your starting number, let's say it's n equals 1. You start at the first term. You end at the 13th term. And then you have negative 2/3 to the n power. So what this series would look like, if you were to draw it all out, it would be negative 2/3 to the first power plus negative 2/3 to the second power, and you keep on going, keep on adding terms until you get negative 2/3 to the 13th power. Then you hit your stopping number at the top, and so then your 13th power, that's when you stop adding your terms. All right. So, all right, Mr. Manning. Right, it's a term in the sequence that you start at. So maybe instead of doing the at sign, I'll just write the letter at, or the word at. That you start at. All right. All right. Questions, or am I good to clear? All right. I can clear annotations now. Hold up for okay. All right. Am I good to clear? Hold up. Okay, gotcha. Hold up. Oh. All right, I'm gonna clear annotations. Remember, this is all going. I'm gonna post this. I'm gonna make sure that if there's I'll work my hardest to make sure that if there's a digital resource that can help you over winter break, you can have it. So that actually your Pomodoros are as productive as possible. Because I feel like they're more productive with the video than without it. All right. An arithmetic series is the sum of all the terms in the arithmetic sequence. So once again, a geometric sequence is you're multiplying by a common ratio. Arithmetic sequence, you're adding by common difference. So an example, you have your sigma notation. Let's say your starting number is 8. Your stopping number is 15. And this is of 2n minus 5, right? So, example of this playing out is you would have 2 times 8 minus 5 plus 2 times 9 minus 5 plus, and you keep on doing the pattern until you get 2 times 15 minus 5, and then you stop. All right? So, pay attention, focus, because it's very... All right, so yeah, sorry. Draw this in this box. Yeah, so draw this in this box, so I apologize. This should go in this box right here. So yeah, so that's n equals to 8, and the stopping number is 15. That's 15. So so essentially you plug in 8 for n, so 2 times 8 minus 5 plus 2 times 9 minus 5 plus 2 times 10 minus 5 plus 2 times 11 minus 5 plus 2 times 12 minus 5 plus 2 times 13 minus 5 plus 2 times 14 minus 5 plus 2 times 15 minus 5, and then you stop because your index is 15. So pay attention, because this notation allows us to express very complex terms of addition all in one go. All right, so let's look at a new series, an infinite series. An infinite series is one in which an infinite number of terms are added. So let's look at how we express an infinite series. An infinite series has a sigma notation where n is equal to 1, and your stopping number becomes infinity. And you have 1 over well, let's just do an example here. 1 over 2 to the n. All right? So, if you think about it, this problem would be, to add this up, it would be 1/2, because the 1/2 to the first power is 1/2. What's 1/2 to the second power? What's 1/2 to the second power? 1/2 times 1/2 is 1/4, plus 1/4, then 1/2 to the third power. 1/2 times 1/2 is 1/4 times 1/2 is 1/8, right? 1/8 plus 1/16 plus 1/32, and that's going to go on for infinity. And if you think about this infinite series, is that you can add up an infinite amount of terms and not get infinity. Because 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32, you add that up, you won't even get to 1. You'll approach 1, but you won't even get to 1. So you can add an infinite amount of terms, and sometimes your series could converge to a specific problem. So that's an infinite series. Yes, Renee? Yes, you may. All right. A finite series is one in which a finite number of terms are added. So we're going to have k equals 3. Start at 6. All right. And then you're going to have to the 2k. All right. So you're going to, and once again, we've pretty much all our examples up to infinite series have been finite series. So that would be, this would be equal to 2 to the third plus 2 to the fourth plus 2 to the fifth plus 2 to the sixth. All right? You want to do the math out, this is going to be equal to 120. All right? And the last vocabulary term, at least for this verbal vocabulary section, is that a partial sum is the sum of part of a sequence. All right? So let's say you have a sequence that is 2, we'll make it simple, 4, 6, 8, 10, 12, continuing on into infinity. If we want to just take a partial sum of from 2 to 8, so take a partial sum here. Yes. Yeah. So the partial sum, well, in this case, would just be 2 plus 4 plus 6 plus 8, which is going to be equal to 2 plus 4 is 6, plus 6 is 12, plus 8 is 20. So that would be equal to 20. All right. So that's all our verbal vocabulary. All right. Please, if you have any questions, please ask them. At all. On anything. All right. Am I good to clear? Or no? Okay, see some people are still writing. All right. Yes. Yes. Wait. So Olivia, you can do it yourself. You give it back to Olivia. All right. So, am I good to clear? Yes? All right, I'm going to clear. So, it's here, one thing is, sorry, that's a partial sum, not just a partial. Although you could use, if you're a Beyonce fan, you could use partition. All right. So you have the sum of a finite and arithmetic sequence formulas, okay? So when the first and last terms are known, this is called the sum. So this is a sum. All right. This is going to be n is the number of terms. A1 is the first term of the partial sum. An is the last term. So that's the first term, the last term, right? And then that's the n is going to be the number of terms. And the same probability applies here. When the last term is not known, it's going to be the number of terms times 2 times the first term plus n minus 1 times the common difference. All right. This would be the common difference for an arithmetic sequence. And once again, I want you to make a note that you have some of the formulas in your formula sheet, but not all of them. Yeah. So, and what I'm going to have to do for formulas is that during review week, I'm going to have you create a formula sheet. We're going to just practice copying down your formula sheet so that when you're handed your formula sheet on your NCFE, you've practiced that so many times that you can get your formulas down within a minute because you have it all memorized, and then you won't have to panic about forgetting a partial sum formula, 30 minutes into the test. So that part of this would just be rote memorization. You can do that just by practicing over and over again. All right, I'm going to clear annotations. All right. So, finding the sum of a finite arithmetic sequence. All right. Summing the terms of an arithmetic sequence. All right. A corner section of a stadium has 8 seats along the front row. Each successive row has 2 more seats in the row preceding it. This should look like a familiar problem. The top row has 24 seats. How many seats are in the entire section? All right. So how many seats are in the first section? 8. All right. What's the common difference? What's D equal to? So how much each successive row has how many more seats than the row preceding it? 2. So D is equal to 2 because we're adding 2 for each successive row. All right? And then how many seats are in the final row? 24. Okay? So AN. So now we need to determine how many terms are in the sequence, right? Because we don't know the number of seats. So we can use our formula. AN is equal to A1 times, plus, make sure I get my operations right, plus N minus 1 times D. So AN, in this case, we know AN is 24, is equal to A1. What's A1? 8 plus 20 plus N minus 1. We need to find N. So plus N minus 1 times D, which is 2. All right? So subtract each side by 8. And you have 24 minus 8 is 16, which is equal to N minus 1 times 2, which is going to be equal to 2N minus 2. Add 2 to each side. 18 is equal to 2N, which means that N is equal to 9. All right? So let's find our series formula now that we know N is equal to 9. Sn. So what would be our series formula? Well, in abstract terms, you can use your formulas on the back page, but we know the first and the last term. So what's the formula when we know the first and the last term? Well, let's write the general form first. N over 2. Hello.
Hey, Mr. Lau, could you send Manny Smith to the main office for just a moment, please?
Yes, right away. All right. So that's going to be N over 2 times A1 plus AN. Okay? So remember, that's just taking the formula when you know the first and the last terms. So now we just plug in our N values. Sn is equal to 9 over 2 plus A1, which is 8, plus AN, which is 24. So that's going to be equal to 4.5 times 32. Or this would be equal to 9 over 2 times 32. Or, if you want to, you could cross out the 2, make that 16, make that equal to 9 times 16. So that's be equal to 144 seats. All right. So here are any questions? All right, come on, let's make sure we're focusing, dialing in. All right, clear annotations. Any questions? Okay, no questions. Am I good to clear? Not yet. Okay. All right, I'm going to clear. All right, so let's at least try to get through an example with geometrics, okay? So the sum of a finite geometric sequence formulas, all right? So this is when you have a ratio where R is not equal to 1, Okay? So this is going to be the first term times 1 minus r to the term number over 1 minus r. This is for a finite sequence, all right? If you're trying to find the sum of an infinite series where r, absolute value of r is less than 1, then and remember, if absolute value of r is greater than 1, it's going to diverge. All right? Then the series is equal to a1 over 1 minus r. All right? Okay? So it's clear annotations? I mean, because all I did was circle things, so. All right? So you find the sum of a geometric sequence when, I'm sorry. Your pattern is 4, negative 4/3, 4/9, negative 4/27, all the way to 4 times negative 1/3 to the 10th. All right? So let's look at our first term. Our first term is 4, a1. And before we go any further, let's look at. We see that our last term is 10, right? Our last term is 10. So we have to we can use n minus 1 to get the correct exponent. All right, we'll see what we mean by that in just a second. If we have our r value, to find our r value, we can just take any term and divide it by a previous term. So we could do, to find our r value, we could do negative 4/3 divided by 4 over 1, right? Just be equal to negative 4/3 times 1/4. So that means r would be equal to negative 1/3. Okay? And because 4 is the first term, negative 4/3 is the second term, 4/9 is the third term, negative 4/27 is the fourth term, so on and so forth. 4 could be, if a1 is 4, then you could have just an equal 4 times negative 1/3 to the n minus 1. Because that way, when the first term, when n is equal to 1, the first term is going to be 4 times negative 1/3 to the 1 minus 1, which is negative 4/3 to the 0. All right? Now that means that n is going to be equal to 11. Because if that's 1 negative 1/3 to the 10th, and 10, remember that 10 is going to be equal to n minus 1, which means n is going to be equal to 11. Because 11 minus 1 would equal to 10. So n is equal to 11. All right? So when we write this in summation notation, we can have our sigma notation. Our starting number is 1. Our stopping number is 11. We'll have our sequence value, 4 times negative 1/3 to the n minus 1 power. All right? And to find our series, Sn would be equal to, and now we just plug in the values in our formula. 4 times -1 minus -1/3 to the 11th, all divided by 1 minus -1/3. So while it looks complicated, you're generally just taking the values and plugging them into the formula. So this should approximately equal 3.000016935. So remember, this is using the formula. Sn is equal to A1 times 1 minus r to the n over 1 minus r. All right. Have a great day. I'll make sure that